Right, question 3. Compute the voltage drop along a 21 meter length of household copper wire with a certain diameter when it carries 12 ampere current. Right, so I want the voltage drop, so the change in voltage across it when it carries a 12 ampere current. So I can easily find it with this formula. B equal to IR. Now, in other words, I treat the wire as one big resistor. Right, so I have the 12 amperes, I just need the resistance of the wire. How can I find it? Well, I've got a formula for the resistance of a wire as long as I know what material it is, copper in this case, and I know how long it is, and what its cross-sectional area is. I know how long it is 21 meters, and I know its diameter, so from that I can calculate the cross-sectional area. Right, so let's use the formula, same one we used in the previous question. So rho L over A, where this will now be the resistivity value for copper, which I can look up. And let's substitute some values. Okay, so this is rho L over, okay, and again I'll use this formula. Pi over 4 d squared for the area of a circle in terms of the diameter. So pi over 4 d squared, okay, pi over 4, so this becomes 4 rho L over pi d squared, and this I can calculate. Okay, so this is just 4, and okay, what is the resistivity value for copper? Okay, sure, I need to find that again. What chapter is this? It's chapter, what's it, 18 I think. Here it is. It's a pretty low value because it's a very good conductor, and there it is, 1.68 times 10 to the minus 8, almost as good as silver in ohms meters. Ohm meters. Okay, so what's that? 1.68. So 1.68 times 10 to the minus 8 ohm meters. Okay, times the length of the wire, 21.0 meters. Okay, over pi times the diameter squared, and now be careful, it's 1.628 millimeters, but everything has to be SI. So what is this? 1.628, but in meters, I need to put it in meters, squared, right, and that I can calculate. If you just left this as 1.628 millimeters and then not with the 10 to the power minus 3, then your answer would not have been in ohms. Okay, right, okay, so let's calculate 4 times 1.68 times 21, okay, and then divided by pi, divided by 1.628 squared, okay, and then times 10 to the power, and then it's going to be minus 8 plus 6, okay, it's because it's times 10 to the power minus 6 below. Right, so, okay, this is not the final answer, I'm going to use in subsequent calculations, so I'm just going to put some extra digits. If this were a final answer, then I would, well, least amount of significant figures here is 3, so then I would provide it just 3. So, but this should be enough, especially since I'm going to multiply it with the current in ampere, which is just 12 amperes. So I don't think a fourth digit here is going to be necessary. Like I said, it's not a precise rule. Okay, so ohms. I've got the resistance, so now I just have to find the voltage. Okay, so that is 12 amperes times this 0.169 ohm. Okay, and let's see what that is. 12 times 0.169, so what should that answer be approximately? If it was 10 here, it would be 1.6, but it's 12, so it should be more than 1.7 at least. Okay, so 2. Alright, 2. How many significant figures am I going to provide here? The least amount involved is 2 in this case, so I'm going to provide 2. So that would be 2.0. 2.0 volts. Okay, and that's it for the first question, well, for the third question. On to question number 4. Okay, so what do we have here? We've got a 12-volt battery, causes a certain current through a resistor. Okay, so it presumably just the battery and the resistor in the circuit. Okay, so what is the resistance of the resistor? Okay, so just like in the first question, I would reason that this 12 volt is over the resistor as well. So this is simply V equal to IR. So R is V over I, and now we substitute the values. 12 volts over the current is 0.60 amperes. Okay, good. And multiply that and try and develop the habit of expecting what your answer should be. That way you can catch yourself if you accidentally make a mistake typing it in. So this 12 times divided by 0.6. So if it was divided by 0.5, then it would be doubled. If you divide by half, you double it. So, but it's more than half. So if it were half, it would be 24. But this should be around about in the 20s then, low 20s. Okay, so divided by 0.6. Yeah, okay, fine. That's 20. Okay, so this is 20 ohms. All right. Okay, so that's for part A. Part B asks, how many joules of energy does the battery lose in a minute? Okay, and how many kilowatt hours? Okay, so I can find that using the following formula. I can find the amount of energy that is transformed or lost in this battery in this case. Using this formula, and then that gives me watts, joules per second, and I'll just multiply that with the amount of time that has passed. Okay, so the rate at which energy is transformed in the is P is equal to IV. I can use that, or you can use this for this value, then reasoning it's over the resistor, but doesn't, so either one of those three formulas would have worked. So this is 0.60 amperes times the voltage, which is 12 volts, right? So if you calculate that, that's 0.6 times 12, okay, which is 72, which makes sense because 6 times 12 is 72, so 0.6 times 12 would be 7.2, a tenth of that, so 7.2 watts, right? Okay, so this is the rate at which energy is transformed in this circuit, so it would be the rate at which the battery loses energy, 7.2 joules every second. Okay, so now for how long? Over how long of a period? Where is it? In a minute, okay. And they want the answer in kilowatt hours. Well, okay, so they want it in joules first. How many joules of energy? Okay, so that's simple. So total energy, let's continue here. Oh, we started with the second question, B. I didn't indicate it. Okay, B. Okay, so total energy lost in, okay, we can do it two ways. Okay, so first is 60 seconds. So this would be 7.2 watts, which are joules per second, multiplied with 60 seconds. And that is equal to 7.2 times 60, so 432 joules. Okay, so that's the amount of energy lost. So in other words, approximately 430, if you want to just use two significant figures. All right. Okay, now that is in how many joules is lost in a minute. Okay, but they also want kilowatt hours. All right, so the easiest way to go about that is let's repeat this whole process, but for watts, for watt hours. So total energy lost in 60 seconds, which is a 60th of an hour, right? Because a minute is a 60th of an hour. So that would be 7.2, well, let me write watts, multiplied by 1 over 60 hours. Right? So that is equal to 7.2 over 60 watt hours. 7.2 joules per second for an hour. Okay, so what is that? That you can calculate. 7.2 divided by 60. 7.2 divided by 60, so 0.12 watt hours. But we don't want watt hours, we want kilowatt hours. So what would that be? Like if this was 0.12 meters and you want to make it kilometers, then you have to divide by 1,000. Okay, so if I divide by 1,000, so normally 0.12 is times 10 to the minus 1, but if I divide by 1,000, it becomes minus 4 kilowatt hours. Alright, so there you have your energy lost in joules and in kilowatt hours, which is a more appropriate, practical energy unit for large energies. Okay. Now, this is a short way of getting to kilowatt hours. Now, I can do, just for completion's sake, I can do the longer way as well, just to do it in terms of conversion factors, which you know, converting from one unit to another unit, in other words, from one unit of energy to another unit of energy. So we do it as follows. What is a watt hour? A watt hour is 1 joule per second for an hour, which is 3,600 seconds. So it is 1 watt hour is 3,600 joules. So if I say I've got my 432 joules, is therefore equal to 432 joules multiplied by, if I want to change this to watt hours, so then I'd say I want it to be watt hours over joules, and I say 1 hour is 3,600 joules. Okay, and if you so this is 432 over 3,600 watt hours, which you can calculate, which should be the same, 0.12 watt hours, and as we saw there, which is 1.2 times 10 to the minus 4 kilowatt hours. Okay, so this is just the longer way, but it's usually just easier to do it this way. Calculate how much watts you have, and then multiply it with the time period, but in terms of hours. In this case, it was in a minute, in 60 seconds, so I write that as a 60th of an hour. I take my watts, multiply it by a 60th of an hour, and I get my answer immediately in watt hours. Okay, so this would be the simplest way of going it, and this would be the longer explanation of what's going on. Here's the watt hours definition. You use that to write watt hour in terms of joules, and then you can just get from joules to kilowatt hour to watt hours using conversion factor, and of course the other way around if you want it. Right. If you want to convert between the two, this is what you would use. 1 watt hour is 3,600 joules. Okay, so that is question 3 and 4.